So, having covered a bunch of concepts on straight lines, a little bit of exposure to simple problems. We are ready to take on a mixed bag of problems on straight lines, and let's get past this bunch. Fairly simple bunch of problems, but will get us initially acclimatized to all the basic results that we've learned. That's the objective. So, this sheet titled Straight Lines, a Problem Solving Spree. So I'm assuming you would have attempted, those of you who came early would have got a chance to attempt these problems, right? So the first problem of the sheet is about a straight line, say 4x plus y minus 1 equal to 0 is a straight line. Passing through a point A2 comma minus 7 is a point on this straight line. Meets the line BC, whose equation is 3x minus 4y plus 1 equal to 0 at the point B. So this is a line BC. Call it 3x minus 4y plus 1 equal to 0. And the two lines intersect at B. The two lines are known to intersect at B. Find the equation of the line AC. We want to be able to find the equation of the line AC. Given that AB equal to AC, we want to find the equation of AC. Right? That's what we want to be able to do. Now, first of all, this is the line 4x plus y minus 1 equal to 0. This is the line 3x minus 4y plus 1 equal to 0. Very clearly, if AB is equal to AC, this angle theta will be equal to this angle theta. Yes or no? Right? Now, can I find tan theta? Realize that the slope of this line, m1, y equal to minus 4x, so minus 4, right? The slope of this line, m2, 3 by 4, 4y is 3x, etc. So, 3 by 4. And can I find tan theta from this? Tan theta would be mod of, say, m1 minus m2 divided by 1 plus m1 m2. Yes or no? Which is mod of minus 4 minus 3 by 4 divided by 1 minus minus 4 into 3 by 4. Yes or no? 4, 8. So that makes it 19 by 8. That makes it 19 by 8. Yes or no? When I take the mod, where is that plus minus, dude? I'm taking modulus of this number. Why should there be a negative sign here? Huh? You don't understand modulus as of now? But where am I opening? I'm only finding tan of the acute angle between these lines. I'm saying tan theta is mod m1 minus m2 by 1 plus m1 m2. So where am I opening the modulus? Now, suppose the slope of this line is m. Suppose the slope of this line. So if I can find the slope of this 1 plus m1 m2. Yeah. Right? Now, if m is the slope of this line, can I find m? Yes, because tan theta will also be mod of m minus m2 by 1 plus mm2. Yes or no? So mod of m minus m2 by 1 plus mm2, 3m by 4. And that is also tan theta. Mod of m minus m2 by 1 plus mm2, that will also be tan theta. Tan theta, which is 19 by 8. Yes. Okay. So far so good. Yes or no? Right? Now the whole idea is to find m. What does this tell me? This tells me find the slope of a line m that makes an angle theta with a line with slope m2. This is what we, right? But there are two such lines. If you solve for m, no, you will get two values of m, of which one will be minus 4. How do you get two values of m? Now if I have to strip the modulus, in order to solve for m, I will have to strip the modulus. Now when I have to strip the modulus, it would mean a plus minus sign, right? To solve for m, I would have to strip the modulus out. If mod a is b, a will be plus minus b. That's what I would need to do. So this is what happens. So then there will be two conditions, m minus 3 by 4 divided by, please come in, 1 plus 3m by 4, that's equal to plus 19 by 8, one possibility. And the other possibility is m minus 3 by 4 divided by 1 plus 3m by 4 equal to minus 19 by 8 is the other possibility. Yes or no? Between these two, I can guarantee one must be m equal to minus 4, which will give you this line, which will give you this line. I am not seeking this line, I am seeking this line. So what is the other value of m? Have you solved for the two values of m from these two equations? One is m equal to minus 4. Between these two, I can guarantee one must be m equal to minus 4. Minus? Okay. The other value of m is minus? I am assuming what you have done is right. Minus 52 by 89 is the other value. Now m equal to minus 4 is the slope of this line. I am not seeking this line. I am seeking this line. Right? So I take this value, minus 52. That means this line must have a slope minus 52 by 89. Now I know a point on this line. I know the slope of this line. Can I not find the equation of this line? By 89. By 89. So how do I find? Y plus 7 by x minus 2 equals minus 52 by 89. That will be the equation. You can cross multiply and simplify and do the needful, right? Do you understand what y plus 7 by x minus 2, y minus 7 by x minus 2 equals the slope of this line, which is minus 52 by 89. Cross multiply and coagulate terms on the same side and you get the equation of this line. Yes. A point A 5 by root 2 comma root 3 and a point B which is of the form cos square theta cos theta. These 2 points are known to lie on the same side of the line. These 2 points A and B are known to lie on the same side of the line, 2x minus y minus 1 equal to 0. These 2 points are known to lie on the same side of the line. We need to find the values of theta in the interval. We need to find the values of theta in the interval pi to 2 pi. We want to find values of theta belonging to the interval pi to 2 pi for which A and B lie on the same side of the line. Right? Now if A and B lie on the same side of this line, that means the sign imparted by the coordinates of A to this must be the same as the sign imparted by the coordinates of B to this expression. Right? Let me find out the sign imparted by the coordinates of A to this expression. Right? So sign imparted by A is going to be 2 into x, which is 5 by root 2, minus root 3 minus 1. So this is like 5 root 2 minus root 3 plus 1. Yes or no? Do you realize this is 5 into 1.47 roughly, and this is 2.7? So very clearly positive, very clearly positive. That means this point imparts to this expression a positive sign. So cos square theta comma cos theta will also impart a positive sign to this expression, which means 2 into cos square theta minus cos theta minus 1 will be greater than 0. So B, which is like 2 cos square theta minus cos theta minus 1 will be greater than 0. Yes or no? Isn't it? Or we have 2 cos theta plus 1 into cos theta minus 1 greater than 0. Yes or no? 2 cos theta, if you factorize this, right? Write this as minus 2 cos theta plus cos theta, right? This is what happens. Now, realize that cos theta is always less than 1. So cos theta minus 1 is less than 0. Cos theta minus 1 will be less than 0. That means this also has to be less than 0 so that the product is greater than 0. Yes or no? Cos theta minus 1 is negative, right? So 2 cos theta plus 1 should also be negative so that the product is positive. Yes or no? And I hope all of you understand why this is negative, right? So then theta is such that 2 cos theta plus 1 will be negative, right? That means theta is such that cos theta will be less than minus half. But so I need to find the values of theta in the interval pi to 2 pi, in the interval pi to 2 pi, for which cos theta is less than minus half. Yes or no? Right? Now, let's see how cos theta behaves. Cos theta less than minus half, that means very clearly cos theta is negative. And therefore, the only two quadrants you would have to look at is the second and the third quadrant. But the second quadrant we don't want. We want, therefore, only in the third quadrant. Now, you know how cos theta behaves is as follows. Let me tell you the graph of cos theta versus theta. Theta equal to 0, it's 1. Goes like this, goes up, does this, and so on and so forth. At theta equal to 0, it's 1. At theta equal to pi by 2, it's 0. At theta equal to pi, it becomes minus 1. Minus 1 for this. Yes or no? Right? At theta equal to 3 pi by 2, it again becomes 0. Cos theta becomes 0. Right? Now the quadrant we are seeking is this. Pi to 3 pi by 2 is the interval that we are seeking. Right? Now, in the third quadrant, when is cos theta equal to minus half? Theta equal to 4 pi by 3. Yes or no? In the third quadrant, when is cos theta equal to minus half? When theta is 4 pi by 3. Do you all understand this? Right? So we are only talking of the third. In the second quadrant, when theta is 2 pi by 3. But in the third quadrant, when theta is 4 pi by 3, cos theta becomes minus half. Yes or no? So at 4 pi by 3, cos theta becomes minus half. This is minus half. This is minus half. Now, obviously, we are seeking this interval because in this interval, cos theta is less than minus half, isn't it? Below minus half means less than minus half, isn't it? If theta comes to this interval, pi to 4 pi by 3, if theta belongs to pi to 4 pi by 3, do you realize cos theta will be less than minus half? If this is minus half, this is less than minus half, isn't it? More negative, right? So theta must belong to pi to 4 pi by 3. Theta must belong to pi to 4 pi by 3, so that cos theta is less than minus half, isn't it? If this is theta, this will be cos theta. And very clearly this is less than this, because this is more negative than this. So this is less than this. So cos theta will be less than minus half in the third quadrant, when if theta belongs to pi to 4 pi by 3. If theta belongs to pi to 4 pi by 3, cos theta will be less than minus half in the third quadrant. Clear? Same thing.
The notes as the general, the angles we take and the intervals, that is how we calculate.
Right. Yes or no? I hope all of you have understood this, huh? Problem now. Let's look at the third problem. Now HK is a fixed point in the first quadrant. Fixed point. And they say that both H and K are positive numbers. So HK belongs to the first quadrant. It's a known fixed point in the first quadrant, right? Now what is done is, there is a straight line which is drawn passing through H comma K. There is a straight line which is drawn passing through P H comma K. Right? And this straight line is drawn in a manner that its intercepts on the coordinate axis are positive. That means it will intersect the positive direction of the x-axis and it will intersect the negative direction of the positive direction of the y-axis. That means I couldn't have drawn this straight line like this, because then it would have a negative intercept on the y-axis. The problem says that intercepts are positive on the coordinate axis, right? Okay, so its intercepts are A and B. Clear? Now find the minimum, or rather P and Q is what they say. So let me call this A just to follow the nomenclature of the problem. Just to follow the nomenclature given in the problem. Not that it matters. Yes, please come. Come on. Not a problem. Clear? Now, how many lines can you draw passing through A? Infinite. With each such line passing through A, given that P and Q are intercepts along the positive x and the positive y directions, how many such triangles OPQ can be formed? Infinite triangles OPQ can be formed, right? Different OPQs will have different areas. Different OPQs will have different areas. Of all the areas generated out of different OPQs, we want to be able to find the smallest possible area produced by various OPQs. You know what I'm saying? Yes or no? You understand the problem? Now, different lines passing through A will differ in theta, isn't it? Different lines passing through A will differ in theta. Theta would be different for different lines, right? So this theta would be different for different triangles OPQ. For a certain value of theta, there is this area of the triangle which would be the least it could be, which it would be the least possible. Yes or no? So I need to minimize this area OPQ. Such should be my selection of theta. You know what I'm saying? Very clearly, you know, if P and Q are in the first quadrant, then this theta has to be acute, although the slope is negative, because this angle is obtuse, but this theta is acute. If this theta is acute, then tan theta, cot theta, etc., all will be positive, right? Now, let me first find the area of this triangle in terms of HK and theta. Let me find out the area of this triangle in terms of HK and theta, using very ordinary geometry. Look, if this is a fixed point, HK, this is theta, what is this? Theta? Right. Now, this is very clearly H, and this is K. Yes or no? Right? Then from this triangle, can I say that this length must be K cot theta? Can I say this? K cot theta must be this length, right? Now, this is K units, right? This is K units. This is H units. This is H units, isn't it? Then this length would be H tan theta, would be H tan theta. Yes or no? So I can find the area of the triangle in terms of theta. Half of base into altitude. Yes or no? Half of base into altitude, right? So area of OPQ is half of H plus K cot theta, H plus K cot theta into K plus H tan theta. Yes or no? Half of base into altitude into K plus H tan theta. Yes or no? Is that okay or not okay? Different values of theta will give me different areas. For a certain value of theta, this expression would be the least it could be. We want to minimize this. Now this could be written as half of H into K plus H tan theta into K cot theta is also H into K. So there is a 2HK. There is a 2HK, right? Plus there is a K squared cot theta plus H squared tan theta. Yes or no? H squared tan theta plus K squared cot theta. How about it? Clear? Now, so for different thetas, this will assume different values. For different thetas, this will assume different values. Would you want to believe that H squared tan theta plus K squared cot theta by 2, that's the arithmetic mean of these numbers? Arithmetic mean of these two numbers is this? Yes or no? And they are positive numbers because theta is acute, tan theta is positive, H square is positive. Cot theta is positive, K square is positive. So arithmetic mean of two positive numbers is greater than or equal to the geometric mean. So this must be greater than or equal to square root of H squared tan theta into K squared cot theta. Yes or no? Tan theta cot theta is 1. And root H square K square is HK. Root H square K squared is HK. So this is greater than or equal to HK. Yes or no? Greater than or equal to HK. Right? Which means now realize I could have written this as HK plus H squared tan theta plus K squared cot theta by 2. Isn't it? Which will be greater than or equal to HK plus, since this is greater than or equal to HK, HK Isn't it? HK is equal to HK, but this is greater than or equal to HK. So this expression will be greater than or equal to HK plus HK, which is 2HK. That means this area delta is greater than or equal to 2HK. Yes or no? This area delta is greater than or equal to 2HK. Forget this. Is this not greater than or equal to this? Add HK to both sides. Isn't it? This is greater than or equal to this, which we establish using the AMGM inequality. Add HK to both sides. Clear? That means the minimum area is 2HK. And when does that happen? When does this become equal to 2HK? Question is, when does delta become equal to 2HK? When AM will become equal to GM? This has to become equal to HK. Then delta will become equal to 2HK. And when would AM be equal to GM? When the quantities involved are equal. That's when AM becomes equal to GM, isn't it? When the quantities involved in the AM-GM constitution are equal. That's when AM will become equal to GM. That means this will become equal to HK when h squared tan theta is k square cot theta. This will happen when h squared tan theta is k square cot theta. Theta is acute, right? That means tan theta is k by h. For theta such that tan theta is k by h, writing this as 1 by tan theta. So tan square theta is k square by h squared. Since tan theta and hk are all positive, tan theta will be k by h. So for theta such that tan theta is k by h, the area of this triangle becomes the least it ever could be. Yes or no? And that least value is 2hk. Are you all okay with this or not okay? Sure, na? Everyone sitting here? Four. Let's look at problem number 4. Now, there is a line x plus y equal to 4. Okay? There is a line x plus y equal to 4. And then there is another line which is 4x plus 3y minus 10 equal to 0 is another line. Clear? We want to find all points P on this line. We want to find the coordinates of all points P on this line that lie at a unit distance from this line. 1 unit from this line. We want to find all P's on this line which are at a unit distance from the other line. Yes or no? No. Any point on this line, let's say if it has x coordinate h, if x is h, then y would be 4 minus h. Right? So any point on this line, if x is h, y would be 4 minus h. Right? Yes or no? Now, distance of h comma 4 minus h from this line, how do you find? Replace x by h, y by 4 minus h in this expression. Take the modulus and divide by root 4 square plus 3 squared. Yes or no? So, mod of 4 into h, replacing x by h, plus 3 into y, y is 4 minus h, minus 10 divided by 5. That's a perpendicular distance of P from this line. That is PM. And that must be equal to 1. That must be equal to 1. Yes or no? Which means 4h minus 3h plus 12 minus 2, 10, 2. That must be equal to 5. Yes or no? Right? So now if I strip the modulus, h plus 2 can be plus 5 or h plus 2 could be minus 5. Right? So h could be either 3 or h could be minus 7. Right? Now if h is 3, 4 minus h, the y coordinate, would be 1. The y coordinate of P. And 4 minus h here is going to be 11. That means either I have a point 3 comma 1 on this, P could be 3 comma 1, or P could be minus 7 comma 11. These are the two possible points at a unit distance from this line. Yes or no? No, that was angle bisector. That was angle bisector. Right? Only if I want to determine acute angle, obtuse angle, I said if a1, a2 plus b1, b2 less than 0, only in that case I said. Otherwise there is no compulsion. No. Let's look at problem number 5. Now there is a line, say 3x plus y plus 4 equal to 0 is this line. 3x plus y plus 4 equal to 0 is this line. There is a point P 2 comma 5. There is a point P 2 comma 5. We want to find the distance of this line from the point 2 comma 5 measured parallel to, that means measured along this line. We want to find the distance from the 2.2 comma 5. See, is 2 comma 5 a point on 3x minus 4y plus 80 equal to 0? 6 minus 20? No, it's not. Right? We want to find the distance of P2 comma 5 measured parallel. That means PQ is what I want to find, such that PQ is parallel to 3x minus 4y plus 8 equal to 0 is what I want to find. Yes or no? Right? Now, very simple. First of all, if PQ is parallel to this, what's the equation of PQ? 3x minus 4y plus some lambda equal to 0 is the equation of PQ. And how do you find lambda? 2 comma 5 lies on this line, right? So 3 into 2 minus 4 into 5 plus lambda equal to 0? Yes or no? 3 into 2 minus 4 into 5 plus lambda equal to 0. That gives me lambda equal to 14. 20 minus 6, 14. That means the equation of this line is 3x minus 4y plus 14 equal to 0. Right? Hey, you know the equation of this line. You know the equation of this line. Can you find the coordinates of Q? Point of intersection of these two lines. Right? Can you tell me what that is? 3x plus y plus 4 equal to 0. How much? Minus 2 and 2. So Q, as he says, the point of intersection is minus 2 comma 2. And then the distance between them would be PQ. PQ would be the distance between, this length is what we want to find. So 16 plus 9, 25. So 5 units. PQ would be 5 units. Distance formula. Yes or no? Let's look at problem number 6. Now, there is a line drawn from P 4 comma minus 5. We want to find the equation of a line drawn from P 4 comma minus 5 such that its distance from Q is minus 2 comma 3, such that its distance from Q, which is minus 2 comma 3, is 12 units. 12 units. We want to find how many such lines can be drawn through P whose distance from Q is 12 units. Yes or no? Now, let's draw PQ. Now, do you realize this length 636 864. 10 units. In this right angle triangle, can the hypotenuse be less than this? This is not possible. Can you ever have this state where the hypotenuse is 10 and this is 12? So this is never possible. This is never possible. You can never draw a line passing through P whose distance from Q is 12 units. Not possible at all. Do you understand why? Sure now? How can you have this less than this? Right? Stand by. Right. Let's look at problem number 7. Let's look at problem number 7. An isosceles right angle triangle ABC isosceles right angle triangle ABC with BC equal to AC slides on the axis, means coordinate axis, with A and B on X and Y axis respectively. Let's assume in the first quadrant. Let's assume for definiteness in the first quadrant. Say A, B here, and C is a point such that BC is AC, and ABC is right angle. Now it's a right angled isosceles triangle, isn't it? This is equal to this, right? BC is AC. That means something like this. This is how it should be. BC equal to AC. That means the right angle must be at C, and it's an isosceles triangle, right angle triangle, so 45 degrees, 45 degrees, yes or no? Such must be the disposition of the triangle ABC, isosceles right angle with BC equal to AC. Clear? Now, this is AB, and C is such that at C you have a right angle. That means such must be C. H comma K says that this is right angle. BC is AC. Yes or no? I want to find the locus of C. So as a special case, yes, it can be on the origin. I'm not denying that. C could be a point on the origin. C could be the origin. Very true. So this is like a rigid wireframe, right? And this rigid wireframe, you keep orienting different ways. C will have a path to pursue. C will have a trajectory associated with it. C will have a locus, right? So while I keep reorienting this triangle ABC, which is like treated like a rigid wireframe, then the point C has a trajectory to tell, right? I want to find the trajectory of C while this triangle ABC is continuously reoriented in the plane, right? Now, one way is we could get really brutal about things and go wild on things here, but some simple observations, very simple observations. This is 90 degrees, and of course this, as you can see, is 45. This is 45. Yes or no? Right? Now this angle plus this angle is how much? 180. What's the nature of this triangle BOAC? Cyclic quadrilateral. Nature of this quadrilateral is cyclic. That means ACBO is a cyclic quadrilateral. Yes or no? That means ACBO, they are points on the same circle, they are points on the same circle, yes or no? Are they not points on the same circle? Now, look at this. If they are points on the same circle, then this angle must be equal to this angle. Angles in the same segment. Right? If this is 45 degrees, this must also be 45 degrees. And this whole thing is 90 degrees, so how much must this be? 45 degrees. That means HK is such that the slope of this line will be tan 45 always. Slope of this line is tan 45, which is 1. Yes or no? Such must be HK. HK must lie on a line passing through the origin and having slope m equal to 1. Yes or no? HK must be a point or a line passing through the origin having slope m equal to 1. So what's the equation of OC? Equation of OC is, so HK lies on this line y equal to x. Isn't it? This is the line y equal to x. A line with slope 1. A line with slope 1 and passing through the origin. Yes or no? So HK must always satisfy this condition. Y equal to mx. M is 1. So this is the locus of C. HK always satisfies this condition. Y equal to x. See? K minus 0 by h minus 0. K minus 0 by h minus 0. That's the slope of this line, which must be 1. So K must be equal to h. Generalize. Put K equal to y, h equal to x, or y equal to x. That's the locus of C. That's the locus of C. A straight line passing through the origin with slope 1. Yes or no? Let's look at problem number 8 now. Let's look at problem number 8. So now, there is a straight line drawn through the origin. There is a straight line drawn through the origin. Say this is the x-axis. And it intersects this curve. This curve is, say, x minus 1 whole square plus y minus 1 whole square is 1. This you will learn is a circle with center 1, 1, radius 1. But even if you didn't know this, it's okay. There is a straight line drawn through O, intersecting this as at A, comma, A and B, right? And there is another curve which is, say, x minus 2 whole square plus y squared equal to 1, and there is another straight line drawn through O, intersecting the curve at C and D. All right. Now it is given that OA, OC, OA, OC, OD and OB are in arithmetic progression. It's given that OA, OC, OD and OB are in arithmetic progression. We want to find the equation of this line. I mean, this is the same line. This is the same line, right? I've just drawn it in two different views. It's the same line that I'm talking of, but I've just drawn it in different views, right? So this angle theta, this angle theta. I mean, it would have created a clutter if I had drawn them on the same view. It's the same line, making an angle theta with the positive direction of the x-axis, intersecting this curve at A and B and intersecting this curve at C and D, such that OA, OC, OB, OD, OB are in AP. We want to find the equation of this line. Yes or no? Equation of this line means what? If I know that the line passing through the origin, then it suffices to know the slope of this line. Tan theta is all that. Then I know that the line would be y equal to x tan theta would be the equation of this line. M would be tan theta, right? A line passing through the origin with slope tan theta would be y equal to x tan theta, right? Now, see, any point on this line passing through the origin. This is a line making an angle theta, right? If I take any point on this line at a distance r from O, do you realize that the x coordinate of this point would be r cos theta and the y coordinate would be r sin theta? So at a distance r from O, if I choose a point P, then that point P would be r cos theta and r sin theta. Different r's will give me different points P on this line. Different values of r will give me different P's on this line, right? For a certain value of r, a certain P, which is r cos theta comma r sin theta, would intersect this curve. How do you find the intersection of this with the point P? Well, if P lies on this curve, it would be the point of intersection of this curve with this line, yes or no? This is a point by its very design on this line. If this also satisfies this equation, then it will be that P will be the intersection between the line and this curve, yes or no? See, this for sure, if it's of the form r cos theta comma r sin theta, it's a point on this line. Now if this P also satisfies this equation, then it will be a P not only lying on this curve but also on this line, yes or no? So that's what I'm seeking to find. That P will be A and B. There are two positions of P which will intersect the curve. P could be A or P could be B, yes or no? So put x as r cos theta, y is r sin theta. So r cos theta minus 1 whole squared plus r sin theta minus 1 whole squared equal to 1. Right? R is the distance of O from P, where P is the point of intersection between this line and this curve. R is general, right? Now this gives me r squared minus 2r cos theta plus sin theta plus 2 minus 1 equal to 0. I get a quadratic in R. That means the intersection of this line with this curve would be r equal to r of A and r equal to r of B. The two values of r would be, one value of r will represent OA, the two roots of this, the other value of r will represent OB, yes or no? The two roots of this quadratic, r equal to OA and OB, yes or no? The two roots of this quadratic would be r equal to OA and r equal to OB, because both for r equal to r of OA and r of OB, there would be intersection of this line with the curve. Are you all okay with this? There are two values of r, right? This. See, I want to find that value of r for which P lies on this curve also. That's what I want to find, right? See, different P's, different values of r will give me different points on this curve. This is r, right? Different values of r will give me different points on this curve. A certain value of r will cause this point P to lie on the curve. So if the coordinates of P satisfy this equation, then that value of r will give me r of OA and r of OB, r for A and r for B. That means yes or no? R for A would be OA, R for B would be OB. R represents the distance of the point P from O. In this case, yes or no? So, if I plug in x is r cos theta, y is r sin theta, then I get the intersection of this curve with this line, the r of the intersection of the curve with the line, right? The two values of r would be r of A and r of B. R of A would be OA, r of B would be OB. Yes or no? These would be the two roots of this quadratic in R. Yes or no? Huh? Now, the sum of the roots, OA plus OB, sum of the roots OA plus OB would be what? Minus B by A twice cos theta plus sin theta. Yes or no? That's OA plus OB. Are you all okay with this? Right? Now, again, for a certain value of R, you will get C and D, right? Some R's will give you R cos theta and R sin theta. That will be the point C and D. How do you find R of C and R of D? Well, if this point lies on this curve, then the two values of R obtained would be R of C and R of D, right? So if this satisfies this equation, it gives me again a quadratic in R. Two values of R. One would be R of C, the other would be R of D. Yes or no? Huh? So, put x as R cos theta, So r cos theta minus 2 whole squared plus r squared sine square theta equal to 1. Yes or no? This gives me r squared minus 4r cos theta plus 3 equal to 0. Yes or no? I hope all of you understand whatever I've done here. It's a quadratic in R. One value of R would be R of C, the other value of R would be R of D. R of C means OC. R of D means OD. That means the root of this quadratic would be, the roots of this quadratic would be R equal to OC and OD. OC and OD would be the roots of this quadratic. Yes or no? That means OC plus OD. OC plus OD, the sum of the roots would be 4 cos theta. Hey, come down to this. OA, OC, OD, OBR and AP. Sum of members equidistant from the beginning and end is the same in an AP. That means can I not say that OA plus OB, first and the last term is OC plus OD? Can I say this? That's a property of an arithmetic progression. Sum of terms equidistant from the beginning and end is the same. So OA plus OB must be equal to OC plus OD. And that means this OA plus OB is twice cos theta plus sine theta equal to 4 cos theta. 2 cos theta is 2 sine theta, or tan theta is 1. That means the slope of the required line is 1, right? The slope of this line is 1. Tan theta is 1, theta is 45 degrees, right? And therefore the equation of a line passing through the origin and slope m equal to 1 would be y equal to mx, y equal to x, m is 1. That's the equation of the required line. Yes or no? Right? Problem number 9. There are two lines given to us. This is one line. Call it 12x plus 5y minus 10 equal to 0. 5x, 12x plus 5y minus 10 equal to 0 is one line. There is another line which is 3x plus 4y minus 5 equal to 0. Right? There are four regions created. There are four regions created here. Now, in one of the regions, the point P 1 comma 1 will lie. In one of the regions, the point P 1 comma 1 will lie. Right? One region, second region, third region, fourth region. Right? In one of the regions, the point 1 comma 1 will lie. Now, there is, of the two angle bisectors between the two lines, there would be one angle bisector passing through this region. There would be one angle bisector passing through this region. Yes or no? There would be one angle bisector passing through the region containing 1 comma 1. We want to be able to find the equation of the angle bisector passing through the region containing 1 comma 1. That means we, in common parlance, we say find the angle bisector containing 1 comma 1. It means passing through a region containing 1 comma 1. Right? Now, equation of the two angle bisectors. Say, on this angle bisector, I select a point A, h comma k. On this angle bisector, I select a point h comma k, the one containing 1 comma 1. One passing through a region containing 1 comma 1. Now, evidently, distance of hk from this line must be equal to distance of hk from this line. For any hk on this proposed angle bisector, if this is an angle bisector, then distance of HK from this line must be distance of HK from this line, isn't it? So how do you find distance of HK from this line? Mod of 12H plus 5K minus 10 by 13, root 12 square plus 5 squared. How do you find distance of HK from this line? Mod of 3H plus 4K minus 5 divided by root 3 square plus 4 squared. Yes or no? Right? So distance of HK from this line is mod of 12H plus 5K minus 10 divided by 13. Yes or no? And that must be equal to distance of HK from this line, which is mod of 3H plus 4K minus 5 divided by root 3 square plus 4 square, which is 5. Yes or no? Are you all okay with this? Now, look at this point 1 comma 1 and this point H comma K. They lie on the same side of this line. 1 comma 1 and H comma K, they lie on the same side of this line. That means the sign that 1 comma 1 imparts to this must be the sign that HK imparts to this expression. Yes or no? Because 1 comma 1 and HK lie on the same side of this line. Now let me see the sign that 1 comma 1 imparts to this expression. The 12 into 1 plus 5 into 1 minus 10, that's a sign 1 which is greater than 0. Yes or no? Which is greater than 0? And if this is greater than 0, then HK must also impart a positive sign to this. Yes or no? That means very clearly 12H plus 5K minus 10 must also be greater than 0. If HK is a point on the angle bisector passing through this region, that's guaranteed. 12H plus 5K minus 10 is greater than 0, where HK is a point on the proposed angle bisector. Right? Now, come down to this line. HK and 1 comma 1 are on the same side of this angle bisector also. That means the sign that 1 comma 1 imparts to this expression is the same as the sign that HK imparts to this expression. Now, what's the sign that 1 comma 1 imparts to this? 3 into 1 plus 4 into 1 minus 5, which is very clearly greater than 0. So HK will also impart a positive sign to this expression. That means 3H plus 4K minus 5 is greater than 0. Yes or no? If HK is a point on the angle bisector passing through a region containing 1 comma 1, are you all right with this or not okay with this? Now, hey, if I strip the modulus, I get two possibilities, plus and minus. Now, if HK is a point on this angle bisector, then 12H plus 5K minus 10 is positive. This by 13 is positive. Now, 3H plus 4K minus 5 is positive. So, this by 5 is positive. So, can two positive numbers be related by a minus sign? So, the only possibility here is a plus sign if HK is a point on the angle bisector passing through this region. Yes or no? Yes, sir. And this is true for all HK on this proposed angle bisector. So, what do? Generalize, replace H by X and K by Y to get the equation of this angle bisector. So 12X plus 5Y minus 10 divided by 13 equals 3X plus 4Y minus 5 divided by 5. Cross multiply and simplify, you get the required line. Yes or no? Number 10. Let's look at problem number 10. There is an equilateral triangle with circumcenter at the origin. There is an equilateral triangle with circumcenter at the origin. This is an equilateral triangle, say ABC, and the circumcenter is the origin. And one of the sides, say BC, is along the line x plus y minus 1 equal to 0. We want to find the equation of the other two sides. We want to be able to find the equation of the other two sides. Now, in an equilateral triangle, the circumcenter would be the same as the centroid. Circum will be the same as the orthocenter. Everything will be the same in an equilateral triangle. Now, AD is a line passing through the origin, right? And perpendicular to this line. The slope of BC, as you can see, is -1. So what would be the slope of AD? +1, because AD is perpendicular to BC. Clear? And therefore, AD has slope -1, +1, beg your pardon, and passes through 0, 0. AD is a line passing through the origin with slope 1. So the equation of AD must be y equal to mx. That means y equal to x. M is 1. Is the equation of AD, yes or no? Y equal to mx. A line passing through the origin will always be y equal to mx. But m is 1 here, as you can see. So that's the equation of AD. Now, so if AD is y equal to x, BC is x plus y minus 1, then to find D, what do? Solve these two equations to get D. If you solve between AD and BC, you get the coordinates of D, yes or no? So x plus y minus 1 equal to 0. And y equal to x, if you solve, you get x equal to half and y equal to half, yes or no? Put x equal to y, so 2y equal to 1, y equal to half, and therefore x is half. So D has coordinates half comma half. Yes or no? Wait. I'm coming to that. Right, you're right. O is also the centroid. Therefore, AO is to OD will also be 2:1. Right? Yes or no? The centroid, which is synonymous with the circumcenter for an equilateral triangle, will divide the median in the ratio 2:1. Now, A lies on the line y equal to x. A lies on the line y equal to x. That means if the x coordinate of A is h, the y coordinate will also be h. If the x coordinate is h, y coordinate will also be h because it lies on the line y equal to x. Now, using section formula, 0 equal to 2 into half plus 1 into h divided by 2 plus 1. Yes or no? Section formula. So that this gives me h equal to -1. This gives me h equal to -1. Right? Therefore, I know the coordinates of A, -1 comma -1. So coordinates of A would be -1 comma -1. Now, the slope of this, as you can see, is -1. I need to find the slope of this and the slope of this. Now, if I know the slope of this, if I know a point on this, I can find the equation of AB, right? This angle is 60 degrees, right? Now, I need to solve for M. Angle between a line with slope M and with slope -1, tan 60 degrees is going to be mod of M minus -1. So that makes it M plus 1 divided by 1 plus M into -1. So 1 minus M. M2 minus M1 by 1 plus M1 M2. Angle between two lines with slope M and -1. This is what happens. Right? Tan 60 is √3. So I get M plus 1 by 1 minus M as plus minus √3. Or one possibility, if I take M plus 1 by 1 minus M as √3, say, I get M into √3 plus 1 equals √3 minus 1. Right? This gives me M equal to √3 minus 1 by √3 plus 1. I can rationalize if I like. So if I rationalize 3 minus 3 plus 1, 4 minus 2 √3 by 2. 2 minus √3. Multiplying numerator denominator with √3 minus 1. This will become 3 minus 1, 2. This will become √3 minus 1 whole squared, which is 3 plus 1, 4 minus 2 √3 divided by 2, which is 2 minus √3. So one of the two lines would be 2 minus √3. Yes or no? And the other line can be obtained when you take minus √3. When you take minus root 3, the other slope of the other line could have been obtained if you took m plus 1 by 1 minus m as minus root 3. So this will give you m equal to m into 1 plus 1 minus root 3 equals minus 1 minus root 3, or m equals root 3 plus 1 by root 3 minus 1, which will be the reciprocal of this, right? So that will turn out to be 2 minus 2 plus root 3, isn't it? Since they are reciprocals of each other, so that will be 2 plus root 3. That means I know the slope of this line, I know the slope of this line. So how do I find the equation of this line, for example? Y plus 1 by x plus 1 equal to the slope of this line, which let's say is 2 minus root 3. And the other one would be 2 plus root 3. So the two equations can be found, one by taking m equal to 2 plus root 3, the other one by taking 2 minus root 3. So you will give you the two possibilities of the lines. One will give you the equation of AB, the other one will give you the equation of AC. Yes or no? I'm assuming you would have attempted problem number 11 by this time. Let's now have a collective discussion of this problem. So what problem 11 is about a rectangle ABCD whose area is given to be 8 square units. And the equation of the diagonals is known. One diagonal is 8x minus y minus 7 equal to 0. The equation of the other diagonal is 8x plus y minus 17 equal to 0. We want to be able to find the equation of the sides of the rectangle. We want to be able to find the equation of AB, BC, CD and AD of the rectangle. How about it? Right? Now, first things first. You realize that if I draw the angle bisector of the diagonals, the two angle bisectors, this is one angle bisector, call it A1, between the two diagonals, and this is another angle bisector, call it A2. These are the two angle bisectors between the diagonals of this rectangle, right? Now, would you be averse to believing that the angle bisectors A1 and A2 would be parallel to the sides of the rectangle? That means A1 would be parallel to AD and BC. A1, the angle bisector A1 would be parallel to AD and BC. Would be parallel to AD and BC. And the diagonal A2, this diagonal would be parallel to AB and CD. Yes or no? Which means if I find the equations of A1 and A2, I would know the slopes of A1 and A2, and therefore if I know the slope of A1, for example, I would know the slope of AD and I would know the slope of BC. How about it? Right? If I know the slope of A2, I would know the slope of AB, I would know the slope of CD, because the slope of A2 will be the same as the slope of AB and CD, because they are all parallel lines. How about it? Right? Now, the two angle bisectors between 1 and 2. How does one obtain the equation of the two angle bisectors? Between 1 and 2. 8x minus y minus 7 by root 65 equals plus minus 8x plus y minus 17 by root 65. The plus sign will give me equation of one of the angle bisectors. The minus sign would give me the equation of the other angle bisector. Yes or no? Right? Now if I took the plus sign, what do I get? 8x minus y minus 7 equals 8x plus y minus 17. Yes or no? This will give me equation of one of the angle bisectors, which is like 2y equal to 10 or y equal to 5. One of the angle bisectors would be y equal to 5. Yes or no? Right? Let me call this angle bisector A2 as y equal to 5. Let me call this angle bisector A2 as y equal to 5. And a line y equal to 5 is a line parallel to the x-axis. Isn't it? A2 will be parallel to the x-axis, and therefore AB and CD will also be parallel to the x-axis. Yes or no? Right? So one of the angle bisector, which is A2, is y equal to 5. Right? Now, let me take the minus sign. Let me take the minus sign from here. If I took the minus sign, then I get 8x minus y minus 7 equals minus of 8x plus y minus 17. Yes or no? Right? And this gives me 16x equal to 24, or x equal to 3 by 2. Yes or no? This is the equation of the other angle bisector. Let me say this is A1. This is A1, which is x equal to 3 by 2. Yes or no? This is, and y equal to 5 and x equal to 3 by 2 intersect at O. Therefore, what would be the x coordinate of O? What would be the x coordinate of O? This point. X coordinate of O would be 3 by 2, right? X coordinate of O would be 3 by 2. What would be the y coordinate of O? Y coordinate of O would be 5, because it lies on the line y equal to 5. Yes or no? Y coordinate of O would be 5. So the point of intersection of the two diagonals would be 3 by 2 comma 5, and the two angle bisector, this is A1, x equal to 3 by 2, and it's parallel to the y-axis. Parallel to y-axis. Yes or no? This is parallel to y-axis. Now, if it is parallel to the y-axis, very clearly AD and BC will also be parallel to the y-axis. AD and BC will also be parallel to the y-axis. AB and CD will be parallel to the x-axis. How about it? Right? Now, let's go a step further. After having obtained the angle bisectors, now if this be a line parallel to the x-axis, right, this is y equal to 5, a line parallel to the x-axis, yes or no? Then this diagonal makes an angle theta with a line parallel to the x-axis, isn't it? This is a line parallel to the x-axis, right? And this is a diagonal which makes an angle theta with this line. Therefore, would you not want to believe that theta will also be the angle that this diagonal makes with the positive direction of the x-axis? Let's say one of the angles that it makes with the x-axis. Yes or no? And therefore, tan theta should reflect the slope of this line. What should tan theta do? Tan theta should give me the slope of this line, because this effectively, in terms of its orientation, represents the x-axis, because this essentially is parallel to the x-axis. Then tan theta should measure the slope of this line, right? The slope of this line is y equal to 8x. So 8 is the slope of this line. So how difficult is it to accept that tan theta would be 8? Yes or no? Right? See, this you could have written as y equal to 8x minus 7. So 8 is very clearly the slope of this line. And this being a line parallel to the x-axis, this theta must be the angle that this diagonal makes with the x-axis as well, right? Now, let's deploy this fact beyond this point, that the area of the rectangle is 8 square units, right? Now, suppose I choose to call this as A. Say this is O, this point is O. Let me call this, say, P. So OP, say, is B, and AP is A. This triangle, right? This triangle. There are 8 subparts produced by the angle bisectors and the two diagonals, of which one is AOP. AOP is a right angle triangle. This is A units and this is B units. So what would be this side of the rectangle? 2A units, isn't it? This side of the rectangle would be 2A units. What would be this side of the rectangle? 2b units. And 2a into 2b should measure the area of this rectangle, 8 square units. So 2a into 2b is 8 square units. What do you say? Right? All's good, right? So AB then would be 2. AB then would be 2. Now what is tan theta? Tan theta is A by B. Tan theta is A by B. So 8 is also A by B. Isn't it? So I could have written this would lead to A equal to 8B. Right? My objective is to find A and B. Once I know A and B, I know that AD is B units away from this to the right, and BC is B units to the left of this line parallel to the y-axis, right? So equation of AD would be what? Equation of AD would be 3 by 2 plus B. X equal to 3 by 2 plus B. How many of you would not want to believe this? X equal to 3 by 2 plus B. We'll find B, don't worry about it. Now we have ground ready to find B. These two conditions would help us find A and B respectively, isn't it? If this is a line parallel to the y-axis, this and this will also be lines parallel to the y-axis. And if this is x equal to 3 by 2, if this is x equal to 3 by 2, moving in this direction means P would be x equal to 3 by 2 plus B, because I'm moving parallel to the x-axis. So I'm moving parallel in this direction. That means parallel to the x-axis. That means x increases by B units. Yes or no? That means the x coordinate of P would be 3 by 2 plus B, and the equation of AD would be 3 by 2 plus B. What would be the equation of BC? The equation of BC would be x equal to 3 by 2 minus B. Yes or no? Now how do I find B? Plug in A equal to 8B in this. 8B squared is 2. Right? A is 8B, so 8B squared is 2, or this will give me B equal to half. Why not negative? Because A and B by our very choice are lengths, so they would be positive, so I ignore the negative sign. So B is half. So this would be 3 by 2 plus B plus half, so that makes it 2. That makes it 2. This is x equal to 2, and this would be 3 by 2 minus B. 3 by 2 minus B would be 3 by 2 minus half, which is 1. So this line is x equal to 2, this line is x equal to 1. We already have two sides of the rectangle. Very good. Now, how about AB and CD? Look, I have B equal to half obtained. Very clearly, if B is half, plug in B equal to half here, I get A equal to 4. I get A equal to 4. Yes or no? Now, once I have this ready, we are there to perform the last rites on this problem. Let's get on with the business of finding equations of AB and CD, right? All that I needed was A equal to 4. A equal to 4 means this length is 4 units. I go in this direction 4 units, I get AB. I go in this direction 4 units, I get CD. Clear? So A equal to 4 is all that I was seeking to find as my endeavor to find the equation of the other two sides. Now, see, this line is y equal to constant, isn't it? AB and CD are parallel to A2. AB and CD are parallel to A2. That means parallel to x-axis. And therefore, both AB and CD would be of the form y equal to constant. Parallel to the x-axis means y equal to constant. Yes or no? Now, what is A2, for example? A2 is y equal to 5. A2 is y equal to 5. And this is my line AB. And to go from this to this, I would have to move 4 units upwards. Isn't it? A is 4 units, I would have to go 4 units upwards. So if I go 4 units upwards, if this is y equal to 5, this would be y equal to 9 very clearly. Right? That's as far as AB is concerned. Yes or no? Right? Now, as far as CD is concerned, CD is this. This will also be a line parallel to y equal to 5. That means parallel to the x-axis. And I would have to go 4 units down. Isn't it? This is like going 4 units down. This is B I'm sorry, this is A, this is also A. So I'm going 4 units down. So this would be y equal to 5 minus 4, that makes it 1. That makes it as simple as that, isn't it? So what looked like a very complicated problem to begin with, but had very simple parts, very simpler parts. The various elements involved in the problem were simple. All that you had to do was to keep your poise, to keep your calm, and look at the simpler elements one at a time, and the rest got consolidated into a very well-defined solution to the problem, which otherwise might have looked beyond reach to begin with. Is that okay? So then, can I leave you free for some more problems? Right? So have the rest of them attempted before I get back to you. Have fun. Bye-bye. Problem number 12. So, in the xy plane, the vertices B and C of a triangle, B lies on the line 3y equal to 4x. This is a line 3y equal to 4x. And B lies on this line. B lies on this line. Right? And C lies on y equal to 0. Y equal to 0 is what? The x-axis. C lies on y equal to 0, that is the x-axis. The side BC passes through a point 2 by 3 comma 2 by 3. Side BC passes through a point 2 by 3 comma 2 by 3. Side BC passes through a point 2 by 3 comma 2 by 3. Now ABOC is a rhombus. So A is selected such that ABOC becomes a rhombus. A is selected such that ABOC becomes a rhombus. O being the origin, we want to find the equation of BC and the coordinates of A. ABOC being the rhombus, BC passing through 2 by 3 comma 2 by 3, we want to find the equation of BC and the coordinates of A. Yes or no? Now, if the x coordinate of B is h, if x is h, then y would be 4h by 3. Yes or no? How about it? B is a point on the line 3y equal to 4x. So if x is h, y would be 4h by 3. So the coordinates of B would be of the form h comma 4h by 3. H comma 4h by 3 would be the coordinates of B. Now, if it's a rhombus, then OB must be equal to OC, right? OC turns out to be OB. OB is root h squared plus 16h squared by 9, which is 5h by 3. Which is 5h by 3, yes or no? That's OC. Now if OC is 5h by 3, the coordinates of C would be, x coordinate would be 5h by 3, y coordinate would be 0. Yes or no? Now, these 3 points are collinear points. B, say P, and C are collinear points. Now, I can find the slope of BC using these 2 points. How? 4h by 3 minus 0. 4h by 3 minus 0 divided by h minus 5h by 3 minus 2h by 3. I could have also found the same thing. Slope the same would have resulted. If I use PNC, then 2 by 3 minus 0 divided by 2 by 3 minus 5h. Yes or no? Clear? So this will give me like a minus 2 on the left hand side, and the right hand side would be 2 divided by 2 minus 5h, right? So I get 5h minus 2 equal to 1, or h equal to 3 by 5. H equal to 3 by 5? Yes or no? Just by equating slopes obtained from BNC and PNC, which is the slope of BC. Now I know the coordinates of B. H is 3 by 5, B therefore H is 3 by 5, and Y 4H by 3. 4H by 3 means 4 by 5. Yes or no? Right? H comma 4H by 3. 4H by 3 is 4 by 5, right? I know the coordinates of C. See, H by 3 is 1 by 5, H by 3 is 1 by 5. So this would be 1 comma 0. 5H by 3 would be 1 comma 0. अरे H को 3 by 5 डाल दो तो ये 1 comma 0 नहीं आएगा. 1 comma 0 would be the coordinates of C. Right? So far so good. That means this side is 1 unit. This side will also be 1 unit. Now this would be, this line would be y equal to 4 by 5. Yes or no? This is a line parallel to the x-axis. This would be y equal to 4 by 5. A line parallel to the x-axis, isn't it? Is it not parallel to this? This would be y equal to 4 by 5. That means the y coordinate of A would be 4 by 5. Would be the y coordinate of A. And the x coordinate would be 1 more than that of B. X coordinate of A would be 1 more than that of B. So 3 by 5 plus 1, which is 8 by 5. 3 by 5 plus 1, which is 8 by 5 would be. Right? Are you lost? No. Now if you know the coordinates of B, you know the coordinates of C. How do you find the equation of BC? BC would be y minus 0 by x minus 1 equals the slope. Actually we already got the slope from here. Slope is minus 2. Realize that? Without having to find h, we knew the slope. 4h by 3 by minus 2h by 3. That was the slope of BC. So that's minus 2. So y plus 2x equals 2 is the equation of BC. Now there is some curve given, and you don't even have to know what curve it is, what it means. That means all points xy on this curve satisfy this equation. 5x squared plus 5y squared plus 6xy minus 8 equal to 0. All xy's on this curve satisfy this equation, right? Now then we have, let's say, the x-axis, the origin. Different points on this curve would be at different distances r from the origin. Different points on this curve would be at different distances r from the origin in general, yes or no? We want to find the smallest and the largest possible values of r. That means the shortest and the greatest distance of this curve from the origin. R minimum and R maximum. Now, different p's will have different r theta combinations, right? Now if this is a certain p such that this length is r, this is theta, then do you realize that this would be r cos theta, this would be r sin theta. That means coordinates of p would be r cos theta, r sin theta. But since it's a point on this curve, it will satisfy this equation. X will be r cos theta, y equal to r sin theta will satisfy this equation. Right? So plug in x is r cos theta, y is r sin theta. minus 8 is 0. You can take r square, 5r square common from this. You'll be left with cos square theta plus sin square theta, 1. So you have 5r squared plus 6r squared sin theta cos theta equal to 8, right? This gives us r squared equal to 8 divided by 5 plus, now one of the 2's, this is 2 into 3, so 3 into 2 sin theta cos theta, which could be written as sin 2 theta. So 5 plus 3 sin 2 theta. Yes or no? R square would be minimum of r squared, when sin 2 theta is maximum. When sin 2 theta is maximum, when the denominator is maximum, ratio will be minimum, then r square would be minimum r squared. Yes or no? And that will have a value. Plug in sin 2 theta equal to 1. So 8 by 5 plus 3, 1. That makes it 1. So r min would be 1. Minimum distance of this curve from the origin would be 1. Yes or no? Right? Now, r square would be r squared maximum when sin 2 theta is minimum. Sin 2 theta is minus 1. Right? If you plug in sin 2 theta is minus 1, 8 divided by 5 minus 3, 2, which is 4. So r max would be 2. R max would be 2. So minimum distance would be 1 unit from the curve of the origin, and maximum distance would be 2 units. 2 units. And the corresponding slope of the line would be, if sin 2 theta is 1, 2 theta is pi by 4, or theta would be pi by 8, slope would be tan pi by 8, right? Right? And if sin 2 theta is minus 1, then 2 theta would be 5 pi by 4, say, one of the possibilities, 5 pi by 4, right? 2 theta would be 5 pi by 4, third quadrant. Or theta would be 5 pi by 8. The slope in this case is going to be 5 pi by 8, tan 5 pi by 8. So I know the equation of the two lines. OP in one case would be y equal to m tan theta, where m would be this. The other possibility for r max would be y equal to m tan theta, where m would be tan 5 pi by 8. These would be the equation of the two lines corresponding to minimum and maximum distances. Yes or no? Huh? One line would be for r min, the other line would be for r max. Say this would be r min, and for r min, theta is such that theta is 5 pi by 8, and then there is going to be a point Q that will give me r max, and the theta for this is going to be 5 pi by 8. The slope of this would be
R min and R max for specifically that line, and here we are doing for the entire unit.
Huh?
I mean, for R max we separately calculate.
Huh. See, there is one line that will give me r min, there is another line that will give me r max. The slope of the one that will give me r min is tan 5 by 8, pi by 8. One that will give me r max, that will have slope tan 5 pi by 8. Sin, oh sorry, I'm so sorry. 2 theta should be pi by 2. I beg your pardon. Sin 2 theta is 1, 2 theta is pi by 2, theta would be pi by 4. So sorry about that. So m would be tan pi by 4. M would be tan pi by 4. Right. And similarly for sin 2 theta equal to minus 1. Right. So 2 theta would be 3 pi by 2. 2 theta would be 3 pi by 2. So that sin 2 theta becomes minus 1. Therefore theta would be 3 pi by 4. Just fix this. Theta would be 3 pi by 4 for this case. So tan would be tan 3 pi by 4. I'm so sorry about this. Please fix this. I hope you realize the mistake I made. Sine 2 theta is 1, so 2 theta would be pi by 2, theta would be pi by 4. If sine 2 theta is minus 1, 2 theta would be say 3 pi by 2 and theta would be 3 pi by 4. The slope would be tan 3 pi by 4. Yeah. Sorry about that. Clear? Now, problem number 14. Problem number 14. There is a rod of length K. There is a rod of length K that slides in a vertical plane. Say AB. AB is K units and it slides in a vertical plane. That means A and B would occupy different positions along the X and the Y axis. Now, from O, I drop a perpendicular onto AB. P is the foot of the perpendicular from O onto AB. P is the foot of the perpendicular from O onto AB, right? We want to establish that the locus of P, so while AB slides, B occupies different states. So the locus of P, we want to establish is x square plus y squared whole cubed equals k squared into x square y square. That's what we want to show. Locus of P we want to show is x square plus y square whole cubed is k squared into x square plus y squared, given that AB is of constant length, while AB slides, AB is of constant length, and while AB slides, P assumes a trajectory. The locus of the trajectory of P is this. This is what we want to establish, right? Now, if AB is P and say this K and this angle is theta, if AB is K and this angle is theta, would you not want to believe that OA would be K cos theta? OA would be K cos theta? Yes or no? Right? And OP would be, again, as you can see, OA sin theta would be OP. OA sin theta would be OP, isn't it? Look at this right angle triangle. So OA, which is K cos theta, and OA sin theta would be OP, isn't it? Isn't it? OA sin theta would be OP. That means OP is, OA sin theta means OA, this OA I can replace by K cos theta. So this is K cos theta into sin theta. That means OP is K cos theta sin theta. Yes or no? Right? So I know OP is K cos theta sin theta. Now, theta is my parameter because while the rod slides, this theta varies, right? Now this is theta, this is 90 degrees, this very clearly is 90 minus theta, and since this whole thing is 90 degrees, this evidently would be theta, this evidently would be theta, right? This would be the x coordinate of P, and this, say this is D. OD would be the x coordinate of P, and PD would be the y coordinate of P, isn't it? OD would be the x coordinate of P would be OD, and the y coordinate of P would be PD. Yes or no? X coordinate of P, OD, y coordinate of P, PD, right? Now, check to see that x, which is PD, is OP sin theta, isn't it? X is OP sin theta. OP sin theta means this into sin theta, which is K sin square theta cos theta. That's OP, right? That's x coordinate of P. What's the y coordinate of P? Now if this angle is theta, this is the y coordinate. PD would be the y coordinate. That is OP cos theta. OP cos theta means this into cos theta, which is like k cos square theta sine theta. These are the x and y coordinates of the moving point as a function of the parameter theta. What is it that I want to do? I want to connect the x and y coordinates of this moving point P and eliminate theta. And once I eliminate theta, I would know that it's going to give me a condition independent of theta, which would be true for all positions of P. Yes or no? Right? Now, if I square x and y and add, if I square and add these two things, 1 and 2, x square plus y square, what do I get? I get k square sine to power 4 theta cos square theta plus cos to power 4 theta sine square theta is what I get, right? That's x square plus y square, isn't it? K square sine to power 4 cos square theta plus cos to power 4 sine square theta, which is like k squared sine square theta cos square theta. I take common, right? From these two terms, I take sine square theta plus sine square theta cos square theta common. Then within the parenthesis, I am left with sine square theta plus cos square theta is what I am left with. Yes or no? Sine square theta plus cos square, which is like k squared. This is 1 sine square theta plus cos square theta, which is k squared sine square theta cos square theta. Right? That's x square plus y square. Now when I cube this, because I want to have a cube of this, when I cube this, I get x square plus y squared whole cubed equals k to power 4, k to power 6, beg your pardon, into sine to power 4, sine to power 6 theta cos to power 6 theta is what I get. Yes or no? Right? This I could have written as k squared into k sine square theta cos theta whole squared into k cos square theta sine theta whole squared. This is what I could have done. Yes or no? Right? See, sine to power 4 theta into sine square theta, sine to power 6 theta, cos square theta into cos to power 4 theta, cos to power 6 theta, and there is k square, k square, k square. That makes it k to power 6. So I could have broken this down as follows. Now this is very clearly k squared, and this is x square, square of this, and this is y squared, square of this. So the x and y coordinates of P are related thus. So this gives me the locus of the moving point P given the condition. How about it? Right? Sounds all right? Let's now move on to the last problem. Take a little while to attempt the last problem. We'll then catch you in some time. Bye-bye. Stand by. Problem of the sheet, which is problem number 15. Let's look at the last problem of the sheet, which is problem number 15. Side AB of a triangle. There is a side AB of a triangle which slides on, the triangle is triangle ABC, which slides in a manner this is the triangle ABC, which slides in a manner that, of course, it's not sliding in any manner. All that I'm saying is tan A, it's sliding but not according to this condition. Tan A is given to be P, tan B is given to be 1 by P. Yes or no? Right? So now what's the nature of this triangle? Tan B is 1 by P means tan B is cot A, isn't it? Tan B is cot A. Cot A is what? Tan 90 minus A. Right? That means B must be 90 minus A. That means A plus B must be 90 degrees. A plus B must be 90 degrees. Now, if this angle plus this angle is 90 degrees, very clearly the third angle of the triangle C must be 90 degrees for sure. Angle C must be 90 degrees. Right? Now, this is like a rigid wire frame. ABC is like a rigid wire frame. It is sliding with A and B staying confined to the x and the y axis respectively. C therefore has a trajectory to tell. We want to find the equation of the trajectory of C. Very simple. Now look at this quadrilateral OBCA. Look at this quadrilateral OBCA. Angle BOA is 90 degrees. This angle BCA is 90 degrees. Very clearly, this angle plus this angle is 180 degrees. This angle plus this angle is 180 degrees. So what's the nature of this quadrilateral? It's a cyclic quadrilateral. It's a cyclic quadrilateral. How about it? Does it make sense to you? All right. Now that it's a cyclic quadrilateral, it's the same circle that passes through O, A, B and C. Let me see if I can draw a circle dignified enough. I'm trying. My freehand sketch is not that good, but almost a circle now, right? It's a cyclic quadrilateral because a pair of opposite angles is supplementary, right? This plus this is 180 degrees. Now, all these points lie on the same circle, very clearly. So if this angle is A, would you not want to believe that this is also A? These are angles in the same segment. If this angle is A, this is also A. They are angles in the same segment. They are angles in the same segment. Now, if they are angles in the same segment, this is A. This is very clearly then 90 minus A. That means the slope of OC, if you look at OC, then the slope of OC is going to be tan 90 minus A. Isn't it? Slope of OC is going to be tan 90 minus A, which is cot A. Which is very clearly 1 by P, is the slope, right? And OC, if C, X and Y are the coordinates of C, then OC is a line passing through the origin with M as the slope. OC is a line passing through the origin with slope M. Therefore, what's the equation of OC? The equation of OC is y equal to mx. Yes or no? Where M is 1 by P. So this is x by P. So the equation of OC is going to be x equal to Py. So the locus of C is a straight line passing through the origin with slope 1 by P. As simple as this. Is that okay? Right then, this much for the sheet. In our next sheet, we'll go a little more elaborate with things, but then at the end of the sheet, you would have got some solace out of solving problems because a number of concepts, results got very directly applied here. This much for this time. We'll see you later. Bye-bye.